What is Trusted Network Connect? Trusted Network Connect, or TNC, is a vendor-neutral open architecture for network security. But what exactly does that mean? The best way to understand TNC is to look at the infrastructure of your enterprise, how it's structured, how it interacts with the infrastructure of other enterprises with which you do business, and what challenges it faces. Let's start by looking at infrastructure. Your infrastructure is a network of interconnected devices, users, policies, and information. This network is structured to allow interaction, collaboration, and sharing while accounting for legacy devices, varying levels of access, and multiple standards, among other variables, while managing different levels of security. This functionality alone is a huge challenge. But when your enterprise interacts with another enterprise with its own devices, users, policies, and information, controlled by its own standards and security, the potential for issues, conflicts, and most importantly, vulnerability expands exponentially. Securing those issues, conflicts, and vulnerabilities typically requires an expensive, vendor-specific integration. Protecting your infrastructure with a vendor-neutral, open architecture that leverages legacy devices, standards, and policies in order to save you money is what TNC is all about. A vendor-neutral, open architecture for network security means you're not locked into one vendor, one brand, or one solution. Equally important, you don't have to tear down your existing infrastructure and start from scratch. TNC works with your existing legacy devices and allows you to take security products from different vendors and know they will work together.
Trusted Network Connect, or TNC, was developed by the Trusted Computing Group. The Trusted Computing Group is an industry standards group focused on secure computing, or, as we like to call it, trusted computing. Now, there are really four basic trusted computing problems that TNC addresses. The first is visibility. This lets you see who's on your network, what devices are in use, are those devices secure, and is their behavior appropriate. The second is access control. This allows you to set a policy for your network for what users, devices, and behaviors are allowed. Also, it allows you to block unauthorized users, devices, and behaviors. And finally, you can set different levels of access for different users or groups. The third capability of TNC is automated remediation. Unhealthy devices can be repaired before they get infected or infect others. And the fourth is coordinated security. All your security systems can be integrated in order to share information about what's affecting your network.
TNC addresses these questions through the four basic building blocks of its architecture: the access requester, the policy enforcement point, the policy decision point, and the metadata access point. Additionally, TNC controls how these four building blocks interact. In the TNC architecture, a device that's trying to access a protected network or resource is called an access requester. When an access requester attempts to access a network or resource, its request passes through a policy enforcement point. The policy enforcement point is the guard that grants and controls or denies access. It does this by transferring the information about the access requester to the policy decision point. The policy decision point looks at the policies you've created and decides what level of access should be granted. This information passes to the policy enforcement point, which executes those instructions.
This level of security is adequate for a single network, but additional protection is necessary for larger enterprise-class systems. Monitoring behavior is required through devices such as intrusion detection systems. TNC lets you integrate those solutions with the rest of your network through the metadata access point.
The metadata access point is a database that communicates with your existing security systems and networks to determine who is on your network, what devices are being used, what their behaviors are, and other information. The primary function of the metadata access point is to act as a central nervous system for different security systems and to integrate them without requiring expensive custom integration. It shares data from your network, such as who is on the network, what their role is, what devices are in use, what IP addresses are being used, and so on, with your other security systems so they can do their jobs more efficiently.
The metadata access point can enhance the capability of your computer network defense security products, such as intrusion detection systems. Normally, an IDS would only scan traffic on a network for anomalous behavior. However, the metadata access point enables TNC to know what user behavior is associated with which IP addresses. The system would know port scanning is normal for IP addresses associated with security administrators, but not from those of the sales team. This enhanced situational awareness allows you to better respond to real intrusions and not false positives.
The vendor-neutral open architecture of TNC provides unmatched flexibility for securing your network with assessment options, enforcement options, and policy options. It also allows clients to decide what features make sense in their environment and which ones they want to employ. It adapts to changing circumstances through coordinated and automated remediation to stay ahead of potential threats and manage your network more efficiently. TNC provides a complete set of standards that work with your legacy devices and products from any vendor. That saves you time, effort, and money. What is Trusted Network Connect? Quite possibly the future for trusted computing.